Welcome back to my YouTube channel Sriram Devarajan. Today I am going to discuss another problem from CSIR Net Mathematical Science question paper from the year December 2025. The problem is from part B. The problem is from complex analysis. The problem number is 36th one. It is given gamma of t which is equivalent to 2 plus I plus r e power 2 pi I t. This r denotes radius of the circle. Here the radius is given as 1 comma 2. We have to check for both the radius value 1 and 2, and t belongs to closed interval 0 comma 1. We have to check the 4 option which one is true among the 4. Since the problem is from part B, only one option will be the correct option. First two option both depends on the curve with the radius 1. The third and fourth option depends on the radius r equal to 2. Here the problem r equal to 1. The gamma of t is given. Integral we have to check for tan z dz for all the 4 options. For the first 2 option radius is 1. For the third one and the fourth one radius is 2. For this problem I am going to use argument principle. First of all, write the statement of argument principle before proceeding towards the problem to get the answer. Let f be a narrow matrix in a domain D is subset of complex C and have only finitely many zeros and most let B if C is a simple closed contour in D such that no zeros or poles of F lie on C, then 1 by 2 pi I integral over C f dash of z by f of z dz, which is equivalent to n minus p, where n and p denotes respectively the number of zeros and poles of F inside C each counted according to their order. Each counted according to their order. For this problem, I am going to use argument principle. First of all, F must be meromorphic in a domain D, which is a subset of C, having only finitely many zeros and poles in D. Also in D, we have a C, which is a simple closed contour such that no zeros or poles of C lie on C, means boundary of C. Both these zeros and poles must lie inside C. Then we have 1 by 2 pi I integral over C f dash of z by f of z dz, which is equivalent to n minus p, where n is number of zeros and p is number of poles which lie inside C, each counted according to their order. First of all, in this problem, what is gamma of r of t? 2 plus I plus r e power 2 pi I into t. What is gamma of 1 of t? 2 plus I plus e power 2 pi I t. What is gamma of 2 of t? 2 plus I plus 2 times e power 2 pi I into t. This can be written as sum modulus of z minus of 2 plus I, which is less than 1. This can be written as modulus of z minus 2 plus I, which is less than 2. Center 2 plus I, radius 1. Here center 2 plus I, radius 2. Now integral gamma of over 1 tan z dz. Here the radius is 1. I am going to use first one. Modulus z minus 2 plus I less than 1. Here, which can be written as sin z by cos z dz. Further, it can be written as minus of minus sin z by cos z dz, which is equivalent to minus of f dash of z by f of z dz, which is equivalent to minus 2 pi I n minus p, by using argument principle. Here, what is f of z, which is equivalent to cos z. Since f of z is cos z, there is no poles. Therefore, p equal to 0. You have to find only zeros. To find zeros, equating f of z to 0. That is cos z, which is equivalent to 0, which is equivalent to cos k plus 1 by 2 into pi. For k equal to 0, 1, 2, we get pi by 2, 3 pi by 2. We have to check out of these 0, which one lie inside the gamma with radius 1. Substitute z equal to pi by 2 minus 2 minus I less than 1. Obviously this value not less than 1, it should be greater than 1. For pi by 2 it is greater than 1. Similarly for 3 pi by 2 the value must be greater than 1. There is no 0 lie inside C. Here n equal to 0. Therefore integral gamma with radius 1 tan z dz equal to 0. For this problem, first two option wrong option. I am going to check the same one for the radius 2, that is modulus of z minus 2 plus I less than 2. Here pi by 2 minus 2 minus I less than 2. What is pi by 2? Modulus of 1.57 minus 2 minus I, which is less than 2. Modulus of 1.57 minus 2 minus of 0.43 minus I, which is less than 2. Obviously this value must be less than 2. Here number of zeros equal to 1, because if I check for 3 pi by 2 the value must be not less than 2, it should be greater than 2. For 3 pi by 2 modulus value z minus of 2 plus I must be greater than 2, not less than 2. Therefore number of zeros lie inside the gamma with the radius 2 is only pi by 2. Therefore n equal to 1, p equal to 0. Therefore integral gamma with the radius 2 tan z dz equal to minus 2 pi I 1 minus 0, which is equal to minus 2 pi I. Option third one is the wrong option. Fourth one is the correct option. I will upload more problems from CSIR net mathematical science question paper from the year December 2025. Subscribe my channel, like my channel, share my channel to your friend. Thank you.